Physics Part 129. Number 1. An electron in a particle accelerator is said to have 1 MeV, 1 mega electron volt of energy when it has been accelerated through a potential difference of 1 million volts. Calculate the energy in joules gained by the electron. Number 2, a torch bulb is rated 22.2 volt, 0.25 amperes. Calculate a charge passing through the bulb in 1 second. Calculate the energy transferred by the passage of each coulomb of charge. Electrical power. Remember that P is the rate of doing work or of transferring energy. Remember also that V is equal to W over Q. Divide each term on the right hand side of this equation by time T, so that V is equal to W over T divided by Q over T. W over T is power of P and QLT is the current I. So potential difference is equal to power over current O. V is equal to P over I. W over Q is a quotient, so dividing W by T and dividing Q by T at the same time does not affect the final value because the term T cancel each other out. The power is measured in watts when the potential difference is in volts. The current is in amperes. A voltmeter can measure the PD across a device. An ammeter the current through it. The equation above can then be used to calculate the power in the device. Resistance. Connecting the wires in the circuits are often made from copper because copper offers little opposition to the movement of the electrons. The copper wire is said to have a low electrical resistance. In other words, copper is a good conductor. Some materials, as plastic, are poor conductors. The materials are said to be insulators because under normal circumstances they conduct little or no current. The resistance R of a wire is defined as the ratio of the potential difference V across the wire to the current I in it. Or R is equal to V over T, where the resistance is in ohms, when the potential difference is in volts and the current in amperes. The symbol for ohms is the Greek capital letter omega. We have defined resistance in terms of a wire, but many devices have resistance. The general term for such a device is a resistor. Note that the resistance of a resistor is measured in ohms, just as the volume of a tank is measured in meter cubic. We do not refer to the meter cubic of a tank, nor the ohms of a resistor. The relation between the resistance, potential difference, and current means that for a given potential difference, a high resistance means a small current, while a low resistance means a large current. We've got an example. The current in an electric immersion heater in a school experiment is 6.3 ampere. When the PD across it is 12 volt, calculate the resistance of the heater. Since R is equal to V over I, the resistance R is 12 over 6.3, 1.9 omega. Now it's your turn. The current in the light emitting diode is 20 meter ampere. When it has a potential difference of 2.0 volt, across it calculate the resistance. Next we'll talk about electrical heating in our next video.